All right, welcome back, and now we're going to do another example, and let's take a look at what we have here. We've got A is 12 meters, B is 31 meters, and then the angle A is 20.5 degrees, okay? So, again, A is smaller than B, but let's take a look at H, right? So again, if we draw our triangle, well, let's just solve for H, okay? So again, we've got, how do I want to do this? Let's go, like this. So here's H, here's A, and here's B, right? So we know that sine A is H over B. So H is going to be what? Sine A times B. So B times sine A. Okay? Which is going to be 31 times the sine of 20.5 degrees, okay? And so when we do that, we get approximately 10.86 meters. Okay, now, notice that A is bigger than H, but smaller than B. So that means we're going to have two distinct triangles. Okay? So let's draw out the possible triangles. Okay? So with that in mind, let's do something like this. It'll be something like that, where we have B, A, okay? So now if I draw, let's say again, think of there's a hinge here at C, and I'm going to swing this across. I'm going to get an isosceles triangle that looks something like that. So here's B1, so that's angle B1, but over here where it touches again, I'll call that B2. So now we've got our two possible triangles. Now, A is 20.5, right? So let's find one of the two angles for B, right? Let's solve for one of the two triangles, okay? So let's do sine A over A equals sine B right? Sine B over B. Again, we don't know which one it is, B1, you know, but let's just sign this, solve this. So we've got we're going to solve for sine B, right? So sine B equals the sine A over A, and this is times B, right? So that means I'm going to get B, which is 31. So 31 times sine of 20.5 degrees divided by 12. Okay, so now let's solve this. Okay, so we get 31 times sine of 20.5 divided by 12, and that's sine, right? Okay. Now, there are two angles that are going to solve this. So let's do where is it at? Sine. Let's do this. Hold on. Let me just calculate this. Okay, so 31 times sine of 20.5 divided by 12. Okay. And now what I'm going to do is okay, so now, so 64, approximately 64.8 degrees, right? So if I do this, and so I get B equals the arc sine, right? Arc sine of 31 times sine of 20.5 degrees divided by 12. So, and that's going to be approximately equal to 64.8 degrees. 64.8 degrees. Okay, so now, but there are two angles that are going to satisfy this, right? One we found. Let's call that B1. So B1 is, again, it's less than 90 degrees, so it has to be the acute angle here. So B1, so we're going to call that 64.8 degrees. Now, what's the other one? Well, the other one is going to be the supplementary angle of this one, because again, it forms an isosceles triangle, right? So that means this is going to be 64 because here's H, right? And so if you think about the hinge that swings, the pendulum, it's going to make the same angle with the base. So this is going to be 64.8 degrees. So 64, 64, that means that this angle B2 is going to be what? That's going to be 115.2 degrees, right? If my math is right. 115, so 64. Yeah, 115.2 degrees approximately. If I have that right. Yep. So now we've got our two angles, right? We've got our two possible angles. So this is going to be 115.2 degrees. Okay, so let me erase this so it doesn't look all congested here. So there we go. Okay. So now, what do? Well, now we can solve for both triangles, okay? So that means if this is 20.5, so let's just figure out what the other angles are then. Let's just use the fact that they have to add up to 180 degrees, right? So let's do 180 minus 20.5 minus 115.2. So 44.3, okay, is going to be this one, right? So 44.3, okay? And then what about this one, right? The whole thing, this one. Let's say, so that one is going to be what? 20 points, so it's going to be 180. Minus 20.5 minus 64.8, 94.7. All right. So now we've got C1 and C2. Okay, so now we've got two triangles. Now we can solve for both triangles. Okay. We know A, we know B, so basically it just depends on what C1 and C2 are going to be. So if we look at B1, right? So let's solve for C1. So C1 is going to be from here to here. That's C1. C2 is going to be the smaller triangle from there to there. Okay, so we solve for this B1, right? So let's solve for C1. So that means we'll have C1 over sine of C I guess, yeah, C1, which is 94.7. Yeah, so this will be C1 and this will be C2 as well. Okay, so C1 over sine of C1 is equal to what? It's going to be A over sine A. And so if we're going to solve for C1, then it's going to be C1 is equal to A sine of C1 all over sine of A. And so now, what do we get? We get 12, right? So we get 12 times sine of 94.7 degrees divided by sine of 20.5 degrees. And so if we stick that in our calculator, we are going to get approximately 34.15 meters. 34.15 meters. All right, so there you have it. We've got C1, A, B, and we've got all the angles for that one, right? For the first triangle, we've got A is 20.5, B1 is 64.8, C1 is 94.7 degrees, right? And then we got A is 12 meters, B is 31 meters, and then C1 is 34.15 meters approximately. Okay. Okay. Now there's the first triangle. Now the second triangle we're going to solve for what? C2 and B2. Right? So we got we already got C2. So we're going to solve for, A, B2, C2, and we got the angle is 21.5. A is still 12, B is still 31, right? So the only thing changing is the angles, right? So we're going to use angle B1, B2 and angle C2. Okay? So we're going to set it up again. This time we're going to do C2 over sine of C2 is equal to A over sine A. And so C2 equals A sine of C2 over sine of A, which is equal to what? 12 times the sine of C2, which is 44.3, divided by the sine of 20.5 degrees. Okay, so now we get, when we calculate this, we get approximately 23.93 meters. So approximately 23.93 meters. Okay, and so now we've got the other triangle solved, which is going to be what? It's going to be A is 12, B is 31, C2 is equal to 23.93 meters approximately. And we've got angle A is 20.5, angle B2 is 115.2 degrees, and angle C2 is 44.3 degrees. And there's the second triangle. Okay, so yes, I did take a little bit longer to do this, but again, I wanted to take my time to make sure that we solve for both triangles. All right, have a great day.